Hello everyone. Good evening. So we are in the session 8 of electrostatic potential and capacitor. In the session we will discuss about the idea of capacitor. Okay, so what is the concept of capacitor? The stage we will go and discuss about the important type of capacitor, which is the parallel plate capacitor. Okay, so but in Canada we'll try to discuss about what is the basic idea of this capacitor. Okay, so we'll start with the discussion. First, capacitor what do you call as a capacitor? See, whenever we talk about the charge in electrostatics, okay, so ஒரு idea என்னன்னா எப்படி அந்த charge store பண்றது. So in what way we can store the charge? ஏன்னா நமக்கு charge storage தேவைப்படும். Because when we want to move the charge from one place to other place, right, we'll be required to store the charge. ஒரு இடத்துல we should be able to store the charge. Okay, அந்த மாதிரியான ஒரு charge storing device ன்னு சொல்லலாம். நம்ம charge store பண்ணா இங்க பாருங்க. So if we are able to store a charge, okay, so positive charge இருக்கலாம் or negative charge, whichever it is. Okay, ஒரு wire ஆகட்டும் or any resistor. What is this? This is an electrical device தானா? So typical electrical device is represented by what? ஒரு resistance. நீங்க அப்படியே அதுலேருந்து if you are able to pass the charge means you are able to pass the current. So current pass பண்ணா you are able to derive the energy out of it, right? So we can say capacitor is also what? Energy storing device. And அதுலேருந்து if you are able to take out the charge means in that process என்னாகும்? We will be able to take out the energy also. அதனால we can call the capacitor as what? ஒரு charge storing device ன்னு சொல்லலாம். And also we can call it as what? Energy storing device. ஏன்னா நம்ம charge derive பண்ணும்போது we will be able to get the energy. Mostly the energy will be coming in which form? Electrical form ல வரும். ஓகேவா? So how do you create this device? For capacitance சொன்னா we are thinking of it like what? A charge storing device or energy storing device. Device ன்னு சொன்ன உடனே don't think of ஒரு பெரிய complicated நீங்க யோசிக்காதீங்க. A capacitor can be a simple conductor itself. அப்படியே நீங்க ஒரு conductor எடுத்தா we can call it as a capacitor. ஏன் தெரியுமா? See, look at anything. Say for example you have a ஒரு conductor object which is made up of conducting material. ஓகேவா? இப்போ பாருங்க, we are giving charge to it. நீங்க charge கொடுத்தா what is going to be the property of the conductor? The charge given to the conductor will be accumulated on the outer surface. So whatever the charge given to it, right, and the object at outer surface மேல it will be accumulated. ஓகேவா? இப்போ பாருங்க, this conductor is storing the charge தானா? So we are giving a positive charge, so it is able to store the charge. But இதுல ஒரு limitation என்ன தெரியுமா? We will not be able to store how much ever charge we want. And after some time what is going to happen is the charge normally outside என்ன இருக்கா? What is the medium outside? What is the medium outside this conductor? It is the air, right? Okay, after some time என்ன ஆகும் தெரியுமா? You will see that even the charge will leak through the air. எப்படி? The charge will be leaking through the air. Okay, அது generally ஆகாது. எப்போ ஆகும்? When we increase the charge value to a very high amount. Okay, so when we are increasing the charge value to a very high amount, right, அப்போ என்ன ஆகும் தெரியுமா? Even we will see that some charge will be leaking through the air. So if you take a simple conductor, we can give charge to it. அப்படியே நம்ம அந்த conductor மேல we can store the charge. அதனால என்ன சொல்லலாம்? A simple conductor can be like a capacitor. Okay, but நம்ம charge பண்ணணும்னு சொல்லிட்டு we cannot keep on storing whatever amount of charge we want. ஏன்னா for every capacitor, okay, இப்போ ஒரு conductor எடுத்தா we can call it as what? Capacitor. So for a capacitor, right, there will be some limitation on what is the maximum charge it can store. Okay, generally எதுக்கு மேல depend ஆகும்? At what stage the charge will start leaking to the surroundings. அதை பத்தி நம்ம திருப்பி பேச போறோம். Okay, so at what stage the charge will start leaking into the surroundings. Okay, அதுக்கு ஒரு specific term இருக்கா, we will discuss about it later. But this is what is the simple concept of the conductor behaving like a capacitor. Okay va? Now if you take an isolated conductor, இங்க பாருங்க, we are taken an object which is isolated னு சொன்னா என்ன தெரியுமா, there should be no physical connections. அதுக்கு there should be no physical connections. Okay, take an isolated conductor. For that you are giving a charge q னு வெச்சுக்கோங்க. Then on the surface of the conductor we will have a potential. இங்க v என்ன தெரியுமா, v is the potential on the surface of the conductor. ஞாபகம் இருக்கா, நம்ம இந்த பாயிண்ட் பத்தி பேசியிருக்கோம் ஆல்ரெடி. What is it? If you have a conductor, we are giving a charge to conductor, then potential on the surface of the conductor will be same as potential at each and every point inside the conductor. அப்படிதானா? So that potential you are calling as what? The potential of that conductor. பாருங்க, இப்போ என்ன தெரியுமா, this charge given to the conductor and potential, they will be related to each other. எப்படி, நம்ம சார்ஜோட வேல்யூ இன்க்ரீஸ் பண்ணா what is going to happen? The potential is also going to increase. அப்படிதானா? Because the positive charge, இங்க பாருங்க, if you take a positive charge வெச்சுக்கோங்க, சார்ஜ் இன்க்ரீஸ் பண்ண என்ன ஆகும், அதோட potential value will be increasing. If you take a negative charge, then adile if you add more negative amount means potential is going to become more negative. நீங்க positive charge கொடுத்தா potential is going to become more and more positive. Negative charge கொடுத்தா potential is going to become more and more negative. Okay va? But என்ன பாருங்க, what is the relation we'll have? The charge on that conductor, isolated conductor, will be directly proportional to the potential on the surface of the conductor. இந்த மாதிரி ரிலேஷன் இருக்கும். சார்ஜ் will be directly proportional to the potential. ஏன்னா நம்ம சார்ஜோட வேல்யூ இன்க்ரீஸ் பண்ணா பொட்டன்ஷியலோட வேல்யூ அப்படியே இன்க்ரீஸ் ஆகும். இந்த மாதிரி ஒரு proportional relations இருந்து வெச்சுக்கோங்க, we can convert this into equation by using what? By using a proportional constant. ஓகேவா? இங்க பாருங்க, so we can say that q will be equal to what? Some c into v. இந்த constant c தான் என்னது, capacitance ன்னு சொல்ல போறோம். What is it? Capacitance. So எப்படி நம்ம capacitance define பண்ண முடியும் தெரியுமா? பாருங்க, we can define it like this. Capacitance is the charge needed for increasing the potential value by 1 volt. எப்படி define பண்ணலாம்? Whatever the charge needed to increase the potential value by 1 volt. நம்ம 1 volt potential value increase பண்ணனும்னா what is the corresponding charge that is required? இங்க பாருங்க, so v ஓட வேல்யூ நம்ம 1 substitute பண்ணா what is it? q will be equal to what? c. So this is when v is equal to what? 1 volt. If you want to increase the potential by 1 volt, அதுக்கான whatever the corresponding charge we need to add, that is what will be the capacitance ஓட value. Obviously என்ன தெரியுமா, this capacitance will be a property of this isolated conductor. ஏன்னா ஒரு கண்டக்டர் வந்து இன்னொரு கண்டக்டர் நம்ம ஷிஃப்ட் பண்ணா the value of the capacitance is going to change. The value of the capacitance is going to be changing. இங்க பாருங்க, we are using a new physical quantity called as what? Capacitance. What is the term we are using? Capacitance. Okay, so இங்க நீங்க அப்சர்வ் பண்ணா what is it? If you want to know the SI unit of that particular physical quantity, so SI unit எப்படி வரும் பாருங்க, left hand side என்ன இருக்கா, we have a charge which is what? Coulomb. Coulomb is equal to what? Right hand side la capacitance இருக்கா into what is the potential of SI unit? Volt தானா? அப்படியே அது நம்ம left side எடுத்துட்டு வந்தா it will go to the denominator. பாருங்க, so coulomb per volt, that is the SI unit of the capacitance. What is the SI unit of the capacitance? என்னது? coulomb per volt. But என்ன தெரியுமா, we give it an honorary name, like the way நம்ம already நிறைய physical quantities கேஸ்ல என்னது, we have given name in honor of the scientist who has worked on the particular physical quantity. So எங்க தெரியுமா, the honorary name for the SI unit of that capacitance is farad. So பாருங்க, 1 farad, right? What is 1 farad? FARAD will be equal to what? 1 coulomb per volt. Okay, so farad ஓட symbol என்ன தெரியுமா? Capital F. What is the symbol for the farad? Capital F. But maximum என்ன தெரியுமா, when you look at most of the capacitors, நம்ம observe பண்ண most of the capacitors, and the capacitors ஓட capacitance value will be very small range. So if you look at most of them will be in the range of either millifarad range or microfarad. But if you go to some of these electrical circuits, right, the capacitors used, they can be even in the range of nanofarad or even picofarad. For some very specific devices, we can even have capacitors like you take a a motherboard of a PC or something, there will be a lot of these capacitors. So for some of them, right, the capacitance value will be even in the range of a nanofarad or picofarad. Nanofarad and so now what is it? 10 power minus 9 farad. Pico means 10 power minus 12. Okay, wow. Micro means what? 10 power minus 6. Milli means this is what? 10 power minus 3. This is 10 power minus 6. 10 power minus 9. This is 10 power minus 12. So farad is the SI unit of the capacitance. Okay, what is a farad actually? It is equal to what? 1 coulomb per volt. But maximum case we will either have the capacitance represented in terms of microfarad or we can have the value in terms of nanofarad or picofarad. Farad is a very large quantity. Farad is a very large quantity. Okay, va? Aprom we look at what is the dimensional formula. Whenever we are getting a new physical quantity, right, first thing we look at what is the SI unit of the physical quantity. And we will also look at what is the dimensional formula. So we look at what is the dimensional formula. What is the dimensional formula of the capacitance? The capacitance or dimensional formula. What is the equation we have? Q, charge on that conductor, which we can call it as what? Capacitance. Okay, charge on the capacitor is equal to what? C. C is the symbol used for the capacitance. C into V. So C or dimensional formula Q is what? Either I into T. We can put it as what? A into T. I is the symbol for the current. Sometimes we can also take the symbol as what? A. Okay, va? Divided by the volt. Remember, volt is what? Work per unit charge dana. Volt another work per unit charge. So work is what? Left side it will go to the denominator. Work is what? ml square t power minus 2 divided by charge another 3p I into d varum. Charge another 3p I into d varum. Okay, so in the rendu terms mela poidu. So what is it? I square t square divided by ml square t power minus 2. Okay, wow. So this is what is the dimensional formula. This we simplify panna. What is it? M power minus 1. L power minus 2 varum. Then t power 4. Numerator already or t square irka. Denominator t power minus 2. So numerator it will become what? T power 2 dana. So t power 4 totally t power 4 I do into I square. This is what is the dimensional formula for the capacitance. What is the dimensional formula for the capacitance? What is it? M power minus 1, L power minus 2, t power 4 into I square. Check pannunga. Are you also getting the same answer or not? Okay, Maithili, good. So m power minus 1, L power minus 2, T power 4 வரும் அந்த மாதிரி I power 2. Okay. So இதில் ஒரே ஒரு பாயிண்ட் என்னன்னா, like now sometimes right, the dimensional symbol for current ஒரு சில டெக்ஸ்ட் புக்ஸில் என்ன they will use this symbol I, இன்னொரு இடத்துல they will be using the symbol A. அது மட்டும் we should be keeping in mind. ஓகேவா? So this is about the concept of the capacitance. Okay, but isolated conductor case என்ன தெரியுமா, maximum will be having the spherical conductor. அது ஒரு common example. Okay, so இப்போ என்னன்னா we look at the spherical conductor. So spherical conductor ஓட capacitance எவ்வளவுன்னு சொல்லிட்டு நம்ம பார்க்கலாம். So இப்போ பாருங்க, we are having a spherical conductor of radius r. Okay, and அந்த spherical conductor மேல we are giving a charge q. Now remember, in case of a spherical conductor, right, already நம்ம கிட்ட potential on the surface of the conductor, அது நம்ம கிட்ட ஃபார்முலா இருக்கா, what is it, q divided by 4 pi epsilon naught into r. இதுதானா? This is the potential on the surface of the spherical conductor. If you are giving a charge q, the spherical conductor மேல what is the potential going to be, q divided by 4 pi epsilon naught into r. So இந்த formulas எல்லாம் நமக்கு ஞாபகம் வச்சுக்கணும், the potential formula and field formula because of a spherical conductor, அந்த மாதிரி spherical shell. These results are important. Okay, so பாருங்க, this is what is the potential. இந்த result நம்ம கிட்ட already இருக்கா, we talked about it on the previous discussion. Okay, இங்க என்ன தெரியுமா, if you look at the relation, what is the relation between the charge and the potential, already அந்த ரிலேஷன்ல தான் நமக்கு capacitance ஓட வேல்யூ வரும். So q is equal to what, c into v தானா? So அப்படியே நீங்க சப்ஸ்டிட்யூட் பண்ணுங்க, q is equal to what, c into v is what, q by 4 pi epsilon naught into r. q cancel பண்ணா what is it that you are going to get, in the 4 pi epsilon naught into r அப்படியே left side எடுத்துட்டு போங்க, it will go to the numerator. So பாருங்க, what you have, 4 pi epsilon naught into r is equal to c. So it's a standard result. Another, the capacitance value of a spherical conductor, அதோட வேல்யூ எவ்வளவு, 4 pi epsilon naught into r. So means what, எதுக்கு மேல டிபெண்ட் ஆகும், it depends upon the, பாருங்க, so this value, right, depends upon the surrounding medium. அந்த spherical conductor ஓட surroundingல what is the medium, ஏன்னா because we are considering this to be air, அதனால we are representing the permittivity as what, epsilon naught. அதனால we are representing the permittivity as what, epsilon naught. Okay, அப்படி எல்லாமே if the spherical conductor is kept in some other medium வெச்சுக்கோங்க, then epsilon naught க்கு பதிலா என்ன வரும், epsilon வரும். Okay, so ஒரு பாயிண்ட் என்ன, it depends upon the surrounding medium ஓட permittivity. ஓகேவா? அப்புறம் it depends upon what, the radius of the sphere, அவ்வளவுதான். So it depends upon what, the permittivity of the surrounding medium, and the sphere oda surrounding medium, what is the permittivity value, adukku mele depend agum. Adukaprom it also depends upon what, the radius of the spherical conductor. Okay va? So this is what is the capacitance of a spherical conductor. Idanadi is capacitance value of a spherical conductor. So in the formula namak ஞாபகம் வெச்சுக்கணும், what is it, the capacitance value is equal to what, 4 pi epsilon naught into r. Okay va? When we look at the earth, usually இதுக்கு முன்னாடி நம்ம என்ன சொல்லிருக்கோம், earth is a infinite source or infinite sink, அப்படிதானா? Like you know, when we are connecting any object to the earth, whatever the charge on that object will be just getting transferred, whatever the charge. If you are having a object on which there is a charge, அப்படியே நீங்க earth oda connect panna, that is what we will generally call as what, earthing and solluvom. So earth oda connect panna, what is going to happen, the charge on that particular substance will be getting transferred to the earth. Adanal another we can say earth is a infinite source or a infinite sink. Okay, infinite and sonna very large amount. Okay, but earth shape எப்படி இருக்கும், கிட்டத்தட்ட ஒரு spherical shape மாதிரி தானா? Of course it is not a clear sphere மாதிரி இருக்காது, but we can approximately say it is what, ஒரு spherical shape மாதிரி. And we even know gravitationally, we will talk about this, the radius of the earth will have 6000 approximately 6400 kilometers, adana, which is in terms of the SI unit la, what is it, 6400 kilometer means 6400 into 10 power 3 meter. இது என்ன வருது பாருங்க, 6.4 into 10 power 6 meter. So earth we can consider it like a spherical conductor of radius எவ்வளோ, 6.4 into 10 power 6 meters. நம்ம அப்படியே substitute பண்ணா, what is the formula for the capacitance for a spherical conductor? What is the formula for the capacitance? 4 pi epsilon into r தானா, which means 4 pi epsilon naught value நம்ம கிட்ட இருக்கா. ஓகே, otherwise நம்ம இப்படி பண்ணலாம், என்ன தெரியுமா, what is 4 pi epsilon naught? இது பாருங்க, 1 by 4 pi epsilon naught is the k value in the vacuum or free space. அதோட SI unit என்ன தெரியுமா, what is it, 9 into 10 power 9. So if you have anywhere 4 pi epsilon naught இருந்தேன்னு வச்சுக்கோங்க, then we can substitute it as what, அப்படி reciprocal, what is it, 1 by 9 into 10 power 9. Okay, so 4 pi epsilon naught value என்னது, 1 by 9 into 10 power 9 in terms of the SI unit. Okay வா, so இங்க பாருங்க, what do you have, 1 by 9 into 10 power 9 into r எவ்வளவு, what is the radius of the okay, இது என்னது 6.4 in 10 power 6. both are in terms of the எதில் இருக்கா, SI unit. both are in terms of the SI unit. okay, நீங்க அந்த simplification பண்ணா, you will see that the value will be very small. இங்க பாருங்க, numerator what is the power of 10, 10 power 6 தானா, denominator what is the power of 10, 10 power 9 இருக்கா. numerator என்னது வெறும் 10 power 6, denominator we have 10 power 9. okay, so when you do the simplification, right, இது எப்படி வரும் பாருங்க, 6.4 by 9 into 10 power minus 3. அது பாருங்க, 6.4 divide by 9 10 power minus 3. okay, இது நம்ம அப்படியே கொஞ்சம் rearrange பண்ணலாம். so if you want to tell the value in terms of microfarad வச்சுக்கோங்க. so this is a very important standard result தெரியுமா. sometimes you can expect straight question, like they will ask us what is the capacitance of the earth, assuming it like a spherical conductor. அப்படியா straight கேட்கலாம். so when we know the value, right, we will be able to straight away tick the option and move on. இங்க பாருங்க, that's why we are actually deriving it. so இது என்னது, 6.4 by 9 10 power minus 3, right. so 6.4 by 9 into 10 power 3 into 10 power minus. and now we are trying to convert the value in terms of microfarad. இங்க பாத்தீங்கன்னா, this value is coming in terms of what, farad. why, because we are taking everything in the SI system, அதனால it is coming in terms of farad. இங்க பாருங்க, 10 power minus 3 10 power minus 3 means what, 10 power minus 6 தானா, that is micro. okay, so remaining term is what, 6.4 into 10 power 3, which is 6400 by 9 microfarad. so 6400 by 9 means what, approximately என்ன தெரியுமா, 711 microfarad. 6000 இங்க பாருங்க, 9 7s are 63 தானா, அதுக்கப்புறம் 10 வரும், 9 ones, அதுக்கப்புறம் 10 வரும் திருப்பி. so 711 microfarad. so if you consider the earth to be a spherical conductor, like a near sphere மாதிரி, with a radius of, what is the radius of the earth, 6400 kilometer. அப்படி எடுத்தா, what is the capacitance value, the capacitance value of this earth is what, 711 microfarad. okay va, so this is what is the spherical conductor. so இங்க பாருங்க, this is an important concept. like initially நம்ம என்ன சொல்லிருக்கோம், when we are giving charge to that conductor, right, we cannot keep on giving the charge. after some time, what is going to happen, the surrounding medium, இங்க பாருங்க, for example, இது ஒரு நம்ம conductor எடுக்கலாம். so this is the conductor. we are giving a charge means it will be on the surface of the conductor. the conductor oda surface மேல தான் charge will be residing. okay, outside la what is it that we are considering, generally we are considering it to be air. outside la enna irukka, we are having the air. so air means what, adoda molecules irukum, air oda molecules irukum. okay, but enna theriyuma, if you keep on increasing this charge on the conductor, the conductor மேல நம்ம charge increase பண்ணா, what is going to happen is, the electric field near the conductor is going to increase. Electric field near the conductor is going to increase. அதனால என்ன ஆகும் தெரியுமா, at certain threshold limit the molecules, so normally என்ன இருக்கும், molecules of that surrounding medium இருக்கும். The molecules or ions of that surrounding medium, they will start getting ionized. எதனால? Because if the field is very high, அப்ப என்ன ஆகும் தெரியுமா, when the field is very high, what is going to happen? The electrons, because if you have a molecule, right, இதுக்குள்ள நிறைய electrons இருக்கா, if you are applying a strong field ன்னு வெச்சுக்கோங்க, because if the field is towards the right side, force acting on the electrons will be towards the left side, opposite la varum. But if the field value is very high, right, and the electrons mela whatever the force that is acting, right, and the force value also will keep increasing. So adanal enna agona, the electrons from that respective atoms can come out when the field is reaching some threshold limit. Okay, adukku enna theriyuma, we use a technical term for that, enadhu dielectric strength nu solluvom. For any medium, right, dielectric strength and energy, it is representing the electric field at which the bound electrons and the medium oda molecules agatum or atoms agatum adukulla whatever the bound electrons that are there, right, they will get ionized. They will get what? Ionized. idhukku enna theriyuma, we use the word field emission nu solluvom. So in fact, you know, namakku one chapter irukka, the concept of atoms. Angenana we will discuss about this photoelectric emission. So modern physics we will talk about what photoelectric emission. Photoelectric emission enna theriyuma, so if you have metal, like, you know, the group 1 metals which have low ionization energy, and the madri metal surface mela if you are incidenting some suitable light, appo enna agum theriyuma, the electrons will start coming out of the surface. அந்த ஒரு ப்ரொசீஜருக்கு என்ன சொல்லுவோம், we'll call it as what? The photoelectric emission. Photo means light, because we are incidenting light and electrons are coming out. அதனால what is the word that we say? Photoelectric emission. But இங்க என்ன தெரியுமா, field emission. Because the field is so high near the surface of the conductor, the atoms or the molecules of that surrounding medium, they are getting ionized. So we also call it as what? The breakdown field and சொல்லலாம். Breakdown means what? The dielectric or that surrounding medium will not allow the flow of the charges. But if the field is becoming so high, the atoms or molecules of the medium are getting ionized. So adanala we will see that the charge will get leaked from the conductor. Okay, so what is that corresponding field value going to be called as? Dielectric strength of the medium and solve. That is called as what? Dielectric strength. Okay, so when you look at the you know, the lightning strike, so what is actually happening when the charge from the clouds is reaching the surface of the earth? When the charge from the cloud is reaching the surface of the earth, angana itrika, because the air normally does not allow the flow of the charges. But when the accumulation of the charge is so high, clouds mela when the accumulation of charge is so high, right, appo enna theriyuma, the field will be reaching this dielectric strength. Then, you know, we will see that at that certain point of time, takkana you will see that, you know, the charge transfer is going to happen through that surrounding medium. Okay va? So this is the limit, and this is the limit. This is the limit to tell how much maximum charge we can store on the conductor. You know, the dielectric strength of the surrounding. Dielectric strength of the surrounding, right, is a limit for telling us how much is the maximum charge we can store on the particular conductor. அப்படியே நம்ம infinite amount of charge store பண்ண முடியாது. Every conductor, right, will have only some limit. And the limit நமக்கு எப்படி தெரியும்? Based upon the dielectric strength of the medium. Dielectric strength என்ன தெரியுமா? When you are giving charge to the conductor, and the conductor surrounding electric field value will keep on increasing. So you will reach certain threshold or cutoff and சொல்லலாம். That electric field is what? The field where the surrounding medium or atoms or molecules, they start getting ionized. Appo enna theriyuma, there will be the leakage of the charge from the conductor. Conductor lande you will see the leakage of charge is happening. So what is it called as? The dielectric strength of the medium, which will be fixing what is the maximum charge we can store on the specific conductor. Okay, இங்க என்ன தெரியுமா, if you particularly focus on the air as the medium, என்ன maximum caseல என்ன, we'll keep the substances inside the air only. பாருங்க, the intensity of the electric field, if it is exceeding this value எவ்வளோ, 3 into 10 power 6 Newton per coulomb. So இதனது, this is what is the dielectric strength of the air. இதனது, this is what is the dielectric strength of the air. So பாருங்க, it's a very huge value. So அதனால தான் generally we will not see charges being transferred through air. So only when the electric field is such a high value, right, we will see that charge leakage will happen through the air. அதோட வேல்யூ என்னது பாருங்க, 3 into 10 power 6 Newton per coulomb. மேக்ஸிமம் இந்த மாதிரி கொஸ்டின்ஸ் வராது, லைக் ஸ்ட்ரெயிட் மெமரி இந்த மாதிரி வேல்யூஸ் பேஸ் பண்ணி கொஸ்டின் வராது. பட் இஃப் இட் ஆல் தே ஆர் கமிங் ரைட், we can just take a look at it. Okay, but என்னன்னா, we should know that one thing, that its value is going to be very high compared to the other medium, right? நம்ம மற்ற மீடியம் கூட கம்பேர் பண்ணா, for that air the dielectric strength value is going to be very high. Okay va? So this is about the dielectric strength which fixes the maximum charge that can be stored on the particular conductor. இங்க பாருங்க, radius of a spherical conductor கொடுத்திருக்காங்க 2 meters. இதனது r ஓட வேல்யூ. This is kept in a dielectric medium of dielectric strength. எவ்வளவு? What is the dielectric strength? 10 power 6 Newton per coulomb. The medium of dielectric strength எவ்வளவு? 10 power 6 Newton per coulomb. Okay. Find the capacitance of the conductor and maximum charge which can be stored on this conductor. என்ன நம்ம calculate பண்ணணும்? First we should calculate அந்த கண்டக்டரோட capacitance. அது எப்படி calculate பண்றது? ஸ்ட்ரெயிட் ஃபார்முலா தானா? ஏன்னா ஸ்பெரிக்கல் கண்டக்டர்னு சொல்லிட்டு இருக்காங்க. What is spherical conductor capacitance? Capacitance என்ன? 4 pi epsilon naught into r தானா? Spherical conductor capacitance value என்னது? 4 pi epsilon naught into r. பாருங்க, what is it? So 4 pi epsilon naught ன்னு சொன்னா, I already told you what is it. We can take it as what? 1 by 9 into 10 power 9. SI unit value 1 by 9 10 power 9. Okay va? R எவ்வளவு? 2. R ஓட வேல்யூ 2. Okay, so what is it? Look at this, 2 by 9 into 10 power minus 9 farad. எவ்வளவு? 2 by 9 into 10 power minus 9 farad. So 2 by 9 ன்னு சொன்னா, what is it? So 2 by 9 means what? 0.2 என்னது 2 அப்படியே வரும், 0.22 நானோ farad. 2 by 9 என்னது? 0.22 நானோ farad. Okay va? So this is what is the capacitance of that conductor. So capacitance of the conductor value எவ்வளவு? 4 pi epsilon naught into r. Okay, அப்படியே அந்த radius substitute பண்ணா we will get it. Okay va? So this is how we will find the capacitance. அடுத்தது என்ன? they are asking us what is the maximum charge which can be stored on that particular conductor. அந்த particular conductor மேல what is the maximum charge that can be stored. இது எப்படி நம்ம calculate பண்ண முடியும்? How we can find what is the maximum charge stored on the conductor? எப்படி தெரியுமா? By using that அந்த dielectric strength ஓட value. பாருங்க, நம்ம கொடுத்தது என்ன? It is a spherical conductor, right? இங்க பாருங்க, we are giving a charge q ன்னு வெச்சுக்கோங்க. That is the maximum charge. Okay, for a spherical conductor, right, field எங்க maximum இருக்கும்? Just near the surface. அதோட வேல்யூ என்ன? q by 4 pi epsilon into r square. Okay, so in case of a spherical conductor, okay, field near the surface. ஏன் நம்ம surface கிட்ட தான் எடுக்கிறோம்? because field near the surface is going to be the maximum value. அதை நம்ம பேலன்ஸ் பண்ணணும். Okay, so இதனது the corresponding value if you equate it to the dielectric strength. Dielectric strength எவ்வளவு? 10 power 6. equate பண்ணா இதுல இருந்து whatever the value of charge we get, right, அதுதான் the maximum charge that we can store on that particular conductor. என்ன பண்ணிட்டு இருக்கோம்? we are looking at what is the field near the surface of the conductor. ஏன்னா because due to the spherical conductor, right, field is going to be maximum at the surface. எங்க maximum இருக்கும்? It will be maximum at the surface. So on the field at the surface oda value we are equating it to what? The dielectric strength. ஏன்னா because if you store even small amount of charge more than that, அப்ப என்ன ஆகும்? The charge will be leaking through the surface. So அதனால that whatever the charge that we get here, right, in the relation whatever the charge we get, that represents what? That represents the maximum charge that can be stored on that particular spherical conductor. பாருங்க, what is it? 10 power 6 into அப்படியே இந்த 4 pi epsilon naught into r square right side போகும் numeratorல. So 4 pi epsilon naught means what? 1 by 9 into 10 power 9 into r square. R square ன்னு சொன்னா 4. So everything is in terms of what? SI unit தானா? இதுல பாருங்க, everything. So dielectric strength ஓட value என்னது? 10 power 6 Newton per coulomb. We are taking everything in terms of the SI unit. அதனால என்ன? The charge maximum value will be also coming in terms of the SI unit value. What is the SI unit value of the charge? Coulomb தானா? So பாருங்க, so here 10 power 6 or 10 power 3 it will be remaining. So what is it? Q max ஓட value என்ன தெரியுமா? What is the Q max value? 4 by 9 into 10 power minus 3 coulombs. 4 by 9 சொன்னா what is it? 0.44 millicoulombs பாருங்க. So capacitance value already நம்ம capacitance value நம்ம calculate பண்ணிருக்கோம் first stepல. இப்போ second stepல என்னது? We are looking at what is the maximum charge which can be stored on that particular conductor. பாருங்க, what is it? The maximum charge we can store we will obtain by using what? The dielectric strength relation. So the dielectric strength is equal to the field near the surface. Equate panna adilende we will get what is the maximum charge that can be stored on the conductor. Okay va? So அடுத்து என்னன்னா, when you have charge given to a particular ஒரு conductor மேல we are giving a charge னு வெச்சுக்கோங்க. Charge will be able to transfer from one place to other place if you connect it through a conductor. இப்போ பாருங்க, previously என்னது? We are keeping an isolated conductor னு வெச்சுக்கோங்க. அதுல இருந்து leaking of the charge to the surroundings will be difficult. Only when the field is very high near the surface, when it is able to meet the dielectric strength or value, right, அப்ப என்ன ஆகும்? There will be leakage of the charge. But normally with the charge will not be getting leaked. But how do you look at the charge transfer then? If you want to transfer the charge means inga parunga, so you have an object 1, inga enadhu object 2. You want to transfer the charge from object 1 to object 2 means what you have to do? We have to connect them by using a conductor. Appadha eppadi? We have to connect them by using a conducting wire. Or conducting wire eduthu nama connect panna what is going to happen? We will see that charge will be getting transferred. Inga enna theriyuma? How the charge is going to get transferred? So positive charge or movement will be in one method and negative charge or movement will be exactly in the opposite manner. Eppadi parunga? Positive charges will flow from high potential to low potential. And the mother negative charge or movement paatha, what is it? It will be flowing from low potential and the high potential. Yen eppadi var the difference? Because positive charge is going from high potential and the low potential, but negative charge அப்படியே reverse irukka. It is going from low potential to high potential. ஏன் தெரியுமா? Because charges they will actually flow from a place where they have a high energy to a place where they will have low energy. எப்படி charge movement இருக்கும்? They will flow from where? From a place where they will have high energy to a place where they will have a low energy. ஏன்னா always like இப்போ நீங்க normally water பாத்தீங்கன்னா, if you drop some water somewhere, when you see the movement of the water, right, ஒரு intuitive நம்ம சொல்லலாம் எப்படி இருக்கும்னு சொல்லிட்டு. How that movement of water is going to be? Water is going to always move from higher level இருந்து lower level. அப்படிதானா? So higher altitude level இருந்து it will be going to the lower altitude level. ஏன்னா because higher altitude level இருந்தா the potential energy of the water will be higher. So water always try to go from a higher level to lower level so that it will be able to decrease the potential energy. Anga mattum kadiyadu, in universe, right, every system always tries to decrease the energy of it. Enna the stability is in the lower energy state. High energy state la stability varadu. Stability is always in the low energy state. like in humans also, right? நீங்க பாருங்க, if we are excited for some time, excited என்னது, we will be shouting and then we will be screaming, but அப்படியே can we remain like that forever? பண்ண முடியாது. We will calm down for after some time, right? So we will come to the ground state, which means what? Always, the tendency is what? To be in the low energy state. So பாருங்க, if you look at a positive charge, இங்க என்ன தெரியுமா? I will start with two examples. I'll take a positive charge of plus 2 coulombs. I'll mark two locations. Location A is one and location B is another. இங்க பாருங்க, location A I am taking the potential as 5 volt. Location B I am marking the potential as what? 10 volt. Okay va? So இப்போ positive charge நம்ம எடுக்கிறோம். Positive charge எடுத்தா what is the energy of that positive charge? So இப்போ you are taking a charge Q to a location where the potential is V. அப்போ அந்த charge ஓட potential energy என்ன ஆகும்? Q into V தானா? So Q எவ்வளோ? plus 2, V எவ்வளோ? 5, multiply பண்ணா 5 into 2 எவ்வளோ? 10 joules வரும் பாருங்க. அந்த மாதிரி at the location B எவ்வளோ? 2 into 10, அது என்னது? 20. So we take a positive charge, means location A la what is the energy of that positive charge? 10 joules. Location B la what is the energy of the positive charge? 20 joules. So நீங்க சொல்லுங்க, how that positive charge is going to move? It will move from a place where it is having high energy la இருந்து it will move to the low energy. இங்க பாருங்க, எங்க இருக்க high energy? B la high energy is there, A la lower energy. So it will move from point B to point A. அதனால நமக்கு இங்க observation என்ன வருது பாருங்க, it will move from high potential to low potential. புரியுதா? So positive charge will move from high potential இருந்து low potential. இப்போ positive charge ஓட பிளேஸ்ல நம்ம என்ன எடுக்க போறோம்? நெகட்டிவ் சார்ஜ் எடுக்கலாம். பாருங்க, பாசிட்டிவ் சார்ஜுக்கு பதிலா ஒரு நெகட்டிவ் சார்ஜ் எடுக்கலாம். சேம் அப்படிதான், we are taking location A and location B. அது நம்ம சேஞ்ச் பண்ணக்கூடாது. ஓகே, ஸோ இங்கே பாருங்க, we are taking a negative charge of minus 2 coulombs. Location A la what is the energy of that minus 2 coulombs charge? Charge ஓட value which is minus 2 into அங்கே இருக்கிற potential which is 5. minus 2 into 5 எவ்வளோ? minus 10. So minus வருவீங்க, energy is what? negative. அந்த மாதிரி இங்க location B la charge minus 2 into potential எவ்வளோ? 10. minus 2 into 10 எவ்வளோ? minus 20 தானா? ஸோ நீங்கள் சொல்லுங்க, minus 10 minus 20 எதில் எங்கே கம்மி இருக்கா? நெகட்டிவ், ரைட்? ஸோ minus 20, அதுக்கப்புறம் we will get to minus 15, அதுக்கப்புறம் minus 10. ஸோ this is what? high. இது என்னது? low. minus 20 means lower தானா? minus means higher. ஸோ பாருங்க, how the charges will move. நம்ம சொன்ன மாதிரி always they will go from high energy இருந்து low energy. means what? the negative charge will go from where? எங்க high energy இருக்கா? point A high energy இருக்கா? point A இருந்து it will go to point B. ஸோ இங்க நமக்கு இருக்கிற observation என்ன பாருங்க, it is going from low potential place to high potential place. but basically பார்த்தீங்கன்னா what is the basic understanding? always charges will go from high energy state to low energy state. but நம்ம potential base பண்ணி சொல்லணும்னா what is it? for the positive charges we will see that they are going from high potential place to low potential. but in the case of the negative charges, right, அதோட observation எப்படி வரும்? just exactly opposite வரும். எப்படி? we will see that negative charges will go exactly in the opposite way. they will go from low potential to high potential. but ரெண்டுத்திலையும் basic concept ஒண்ணுதா. what is it? any charge, right, will always go from a place where it is having high energy to a place where it is having low energy. அப்படிதான் இருக்கும். ரெண்டுத்திலையும் basic concept ஒண்ணுதா. but in terms of potential நம்ம observe பண்ணா we will see a difference. positive charge ஓட கேஸ்லயும் negative charge ஓட கேஸ்லயும் we will see a difference. ஓகேவா? so this is how we will see the movement of the charges from one place to other place. but if you look at in very என்ன சொல்றது, ஒரு simple way of understanding how the movement or என்ன சொல்லலாம், redistribution of the charge னு சொல்லலாம். movement னு சொல்றதுக்கு பதிலா, because we will not use the word movement. so mechanics la we will use the word movement னு சொல்லிட்டு, but இங்க என்ன தெரியுமா, we will use the word redistribution of the charges. இங்க பாருங்க, like in case of the mechanical systems, right, like water tanks. say for example you have இந்த பக்கம் என்னது tank 1 இருக்கு, இந்த பக்கம் tank 2. tank 1 we have a higher level. What is it? Water level is high. Tank 1 we are having a higher level of water. Tank 2 கம்மி இருக்கா. இப்போ இந்த பாருங்க, இப்போ நம்ம இந்த வால் ஓபன் பண்ண என்ன ஆகும்? வால் ஓபன் பண்ண உடனே what is going to happen? இந்த tank 1 ல இருக்கிற வாட்டர் அப்படியே இந்த பக்கம் வரும். Till both of them are coming to the same level. இப்படி tank 1 ல இருக்கிற வாட்டர் அப்படியே இந்த பக்கம் வரும். Till both of them are coming to the same level. இதோட எலக்ட்ரிக்கல் அனாலஜி என்ன தெரியுமா? So இங்க என்ன, what is the thing? The water is getting transferred till both of them are coming to the same level. இதோட எலக்ட்ரிக்கல் அனாலஜி என்ன தெரியுமா? இங்க பாருங்க, if you have a conductor, another conductor, okay, so இப்போ நம்ம ரெண்டுத்தையும் கனெக்ட் பண்ணா இதோட கெபாசிட்டன்ஸ் C1 வெச்சுக்கோங்க, இனிஷியல் கெபாசிட்டன்ஸ், வோல்டேஜ் V1. இங்க இருக்கிற கெபாசிட்டன்ஸ் இஸ் வாட்? C2, voltage V2. okay, so பாருங்க, V1 and V2 are initial voltages. okay, நம்ம அப்படியே ரெண்டுத்தையும் கனெக்ட் பண்ணா we will see charge is going to redistribute till when, like in the முன்னாடி நம்ம பார்த்த எக்ஸாம்பிள்ல what is it? Water is moving till when? Till the water level in both the containers is same. அப்படிதானா? it is moving, இந்த பக்கத்துல இருந்து it is coming to this level till both of them are having the same level of water. Electrical systems என்ன தெரியுமா? The charge redistribution is going to happen till both the conductors will have the same potential. So charge redistribution is going to happen till both the conductors have same potential. இதுக்கு என்ன தெரியுமா? We also use the word common potential and சொல்லலாம். இதுக்கு என்னது? What is the word that we can use? Common potential. So அந்த ஒரு சைடுல இருந்து இன்னொரு சைடுல we will have charge transfer happening till both the conductors are having the same potential. So initial என்ன தெரியுமா? What is the charge on the first conductor? Because charge formula என்ன? Capacitance ஓட value into voltage தானா? So initially what is the charge here? C1 into V1. Initially what is the charge here? C2 into V2. okay வா? So total charge, பாருங்க, what is the total charge initially? And initial case what is the total charge? இந்த பக்கம் we are having C1 V1, அந்த பக்கம் C2 V2. total charge means C1 V1 plus C2 V2. அதுதானா? total charge எவ்வளவு? C1 V1 plus C2 V2. finally நம்ம என்ன சொல்றோம்? both of them will come to the same potential. அதனால we will say V is what? common potential னு சொல்லலாம். V என்னது? common potential. ஓகேவா? இப்போ பாருங்க, what is the final total charge ஓட வேல்யூ? இந்த கண்டக்டரோட வோல்டேஜ் எவ்வளவு? வேற காமன் பொட்டன்ஷியல் சொன்னா both will have the same potential, right? இப்போ இந்த கெபாசிட்டருக்கு மேல what is the charge? C1 into V. Second capacitor மேல what is the charge? C2 into V. okay, since charge will not be destroyed, right? அதனால whatever the total charge initially will be equal to total charge finally, which means what? is equal to what? C1 into V plus C2 into V. இதுல என்ன தெரியுமா? அப்படியே நம்ம V காமன் எடுக்கலாம். V காமன் எடுத்தா what you are going to get? C1 plus C2 into V மாதிரி வரும். ஓகேவா? ஸோ இங்கிருந்து என்ன? we will have the final value. பாருங்க, final value for the common potential. இப்போ இந்த C1 plus C2 நம்ம left sideல எடுத்துட்டு வந்தா what is it? It will go to the denominator. So what is it? C1 V1 plus C2 V2 divided by C1 plus C2. இதுதான் common potential ஓட value. So it's a very important result. Anyway, if you are connecting two conductors with initial capacitance C1 and C2 and charge and the potentials are what? V1 and V2. When you connect both of them, the charge redistribution is going to happen till both the conductors are having the same potential. And the potential value we are calling it as what? Common potential. So common potential value is C1 V1 plus C2 V2 divided by C1 plus C2. So in the result, it is coming based on the conservation of the charge. Whatever the total initial charge, the value, we are equating it to what? Total final charge. We are able to get what is this? common potential. So common potential value enna C1 V1 plus C2 V2 divided by C1 plus C2. Okay, so idhula oru point enna theriyuma, we have to keep in mind that the final stage, the potential value on both the conductors will be same. Adu namu naam vechukonu. What is it? The final stage la potential value on both these conductors is going to be same. Okay va? So idu base panni we even got some questions. Past years we got some questions. Paranga. Good, Maithili. Okay. So what is this? Two isolated maximum theriyuma, we will get questions on the isolated spherical conductors mela da varum. So different other type of conductors la we will not get questions. We will have questions mostly on the spherical conductors la varum. Okay. Two isolated spherical conductors have radii 5 cm and 10 cm. Ippadi paranga, we can represent this like a diagram. Idanadi radius 5 cm. Idoda radius evlo 10 cm. Okay va? They have charges 12 microcoulomb and minus 3. Inganadi 12 microcoulomb. Okay, so we have to take respectively. Okay va? Find the charges after they are connected by a conducting wire. இப்போ நம்ம இந்த ரெண்டு இது எடுத்துட்டு we are connecting them by a conducting wire means finally what is the charge on both of them, அது நம்ம calculate பண்ணணும். Okay, இங்க என்ன தெரியுமா, straight away we will go for that formula. நம்ம கிட்ட என்ன formula இருக்கா, final common potential is equal to what, C1 V1 plus C2 V2 divided by C1 plus C2. இதுதானா? What is the final common potential value? C1 V1 plus C2 V2 divided by C1 plus C2. இதுதானா? பட் இங்க என்ன தெரியுமா, நமக்கு இனிஷியல் பொட்டன்ஷியல் தெரியாது. இனிஷியல் பொட்டன்ஷியல் இங்க V1 ஓட வேல்யூ V2 ஓட வேல்யூ தெரியாது. பட் நீங்க இந்த ஃபார்முலா அப்சர்வ் பண்ணா what is C1 V1? C1 V1 என்னது, இனிஷியல் சார்ஜ் on that first conductor Q1. அதுதானா? C2 V2 means initial charge on the second conductor Q2. So in the common potential ஓட வேல்யூ ரைட் இப்படி நம்ம எழுதலாம். What is it? Q1 plus Q2. Q1 means charge, initial charge on the first conductor. Q2 என்னது, initial charge on the second conductor. Okay, Q1 plus Q2 divided by இதை பாருங்க C1 plus C2. So இதுதான் final common potential. இங்க என்ன தெரியுமா, first we'll try to get the C1 value and C2 value. பாருங்க, what is the C1 value? 4 pi epsilon naught into 5 centimeter. இது நம்ம அப்படியே substitute பண்ண வேண்டாம், we'll try to keep it. அந்த மாதிரி C2 எவ்வளவு பாருங்க, 4 pi epsilon naught into 10 centimeter. C1 எவ்வளவு, 4 pi epsilon naught into R. What is the capacitance of the spherical conductor? அதுக்கு formula என்ன, 4 pi epsilon naught into, so for a spherical conductor, right, அதோட capacitance value எவ்வளவு, 4 pi epsilon naught into R. அதுதானா? So the first conductor ஓட capacitance எவ்வளவு, 4 pi epsilon naught into 5 centimeter. Second capacitance, அதோட capacitance value எவ்வளவு, 4 pi epsilon naught into 10 centimeter. ஓகேவா? ஸோ இப்போ நம்ம கிட்ட C1 வேல்யூ இருக்கா, C2 வேல்யூ இருக்கா. Q1 plus Q2 என்னது பாருங்க, what is Q1 plus Q2? Q1 is 12 micro, Q2 is minus 3 micro. So we will try to get what is the common potential value. ஏன்னா common potential value நம்ம கிட்ட இருக்குன்னு வச்சுக்கோங்க, அங்கிருந்து we can calculate what are the final charges. எப்படி, what is the final charge on the first conductor? C1 into V. அவ்வளவுதானா? C1 is the capacitance. அந்த மாதிரி what is the final charge on the conductor 2? C2 into V. அப்படிதானா? So பாருங்க, what we are going to do is we will try to get what is the common potential value. Okay, so இங்க என்ன தெரியுமா, so common potential value என்ன, Q1 plus Q2 which is 12 minus 3. add பண்ணா what is it, 9 micro means what, 10 power minus 6 தானா, divide by denominator இருக்க C1 plus C2. பாருங்க 5 centimeter சொன்னா what is it in terms of the SI unit, 5 centimeter சொன்னா what is it, it will be what, we can take it as what, 0.05 meter. இல்லைன்னா we can for now we can keep it as it is. அப்படியே வச்சு நம்ம கண்டினியூ பண்ணலாம் பாருங்க. So we'll just keep it as it is. So C1 plus C2. So 4 pi epsilon naught into இந்த ரெண்டு வேல்யூஸ் நம்ம ஆட் பண்ணா என்ன வரும் 15 சென்டிமீட்டர் வரும். ஸோ இதில் we are continuing with that சென்டிமீட்டர் அப்படி நம்ம கண்டினியூ பண்ணுறோம். பட் நியூமரேட்டர் இருக்கிறது என்ன SI யூனிட் 9 மைக்ரோ கூலும். ஓகே, ஸோ திஸ் இஸ் த காமன் பொட்டன்ஷியல். இதுதான் காமன் பொட்டன்ஷியலோட வேல்யூ. நவ் ஃபைனல் சார்ஜ் ஆன் C1. So we can call it as what Q1 dash and சொல்லலாம். What is it? C1 into V தானா? C1 is what 4 pi epsilon into 5 centimeter into that common potential value எவ்வளோ 9 into 10 power minus 6 by 4 pi epsilon into 15 centimeter. ஓகே, இது நம்ம கால்குலேட் பண்ணணும். ஸோ 4 pi epsilon இது கேன்சல் ஆகிடும். 5 centimeter once 5 centimeter is பாருங்க. So Q1 dash will be equal to what? இது என்னது? It will be 3 into 10 power minus 6 coulombs, which is what? Which is 3 microcoulombs. 3 into 10 power minus 6 and so on. What is it? 3 microcoulombs. Okay, wow. So then this is the charge on the first spherical conductor once the redistribution is happening. And the மாதிரி we can also calculate what is the charge on that second conductor. அதுக்கு மேலே சார்ஜ் என்ன? let us say it is what Q2 dash ன்னு சொல்லலாம். What is it? C2 into V. C2 எவ்வளோ பாருங்க 4 pi epsilon naught into 10 centimeter into V means what 9 into 10 power minus 6 divided by 4 pi epsilon naught into 15 centimeter. இது என்னது பாருங்க 4 pi cancel 2's 3's. So numerator we have what 2 9s are 18. 18 by 3 means what 6. இது என்னது 6 microcoulombs வருது. So what is the charge on the first conducting sphere? 3 microcoulombs. Charge on the second conducting sphere எவ்வளோ 6 microcoulombs. ஓகேவா, இப்படி நம்ம கால்குலேட் பண்ணலாம். So what we are doing, நம்ம அந்த ரெண்டு ஸ்பியர்ஸ் கனெக்ட் பண்ணால் the final common potential value first. அது என்னது either we will use C1 V1 plus C2 V2 by C1 plus C2 அந்த ஃபார்முலா யூஸ் பண்ணலாம். இல்லைன்னா we can use what Q1 plus Q2 divided by C1 plus C2. ஓகேவா, அதுலேருந்து we are getting what is the common potential. Common potential வந்தால் what is the final charge on the capacitor 1? C1 into V அவ்வளோதான். What is the final charge on the capacitor 2? C2 into V. இங்கே பாருங்க, we have got almost similar question in 2012 paper வந்தது. Two metallic spheres of radius 1 centimeter and 3 centimeters are given charges. எவ்வளோ the charge on that 1 centimeter இங்கே பாருங்க. So charge on that இது என்னது 1 centimeter. அதுக்கப்புறம் we have another one is what 3 centimeters, right? இதுக்கு மேலே what is the charge? minus 1 into 10 power minus 2 coulombs. இதுக்கு மேலே 5 into 10 power minus 2 coulombs. If these are connected by a conducting wire, நம்ம அந்த ரெண்டு ஸ்பியர்ஸ் கனெக்ட் பண்ணால் the final charge on the bigger sphere எவ்வளோ? bigger sphere சொன்னால் radius with 3 centimeter. bigger sphere சொன்னால் what is it? radius with 3 centimeter. இங்கே இருந்து சேம் ப்ரொசீஜர் தான். ஸோ இந்த ரெண்டு ஸ்பியர் நம்ம கனெக்ட் பண்ணியிருக்கோம் using a conducting wire. So what is the formula for the common potential? Q1 plus Q2 by C1 plus C2. அதுதானா Q1 plus Q2. So if you are knowing the initial voltages means we will use this formula. என்னது C1 V1 plus C2 V2 by C1 plus C2. பட் இங்கே நமக்கு அந்த இனிஷியல் பொட்டன்ஷியல் தெரியாது, சார்ஜ் தெரியும். ஸோ அதனால we are using this particular expression. What is it? Q1 plus Q2 by C1 plus C2. அப்படியே நம்ம சப்ஸ்டியூட் பண்ணலாம் பாருங்க. Q1 plus Q2 ஆட் பண்ண என்ன வரும்? இங்கே என்னது -1 தானா, இது என்னது 5. -1 plus 5 means 4. So 4 into 10 power minus 2 coulombs. நியூமரேட்டர் என்னது coulombs divided by C1 plus C2. இங்கே பாருங்க C1 is what 4 pi epsilon naught into இது என்னது 1 centimeter. C2 எவ்வளோ 4 pi epsilon naught into 3 centimeter. ஸோ நம்ம ஆட் பண்ண என்ன வரும் 4 pi epsilon naught into 4 centimeter வரும். 1 centimeter plus 3 centimeter எவ்வளோ 4 centimeter தானா. ஸோ இது என்னது V ஓட வேல்யூ ஃபைனல் காமன் பொட்டன்ஷியல். ஓகே, இதில் நம்ம யூனிட் நம்ம change பண்றதில்லை. ஏன்னா because anyway we will see that they will get cancelled. Finally நமக்கு என்ன ஆகும், we will get things cancelled, right? இப்போ அவங்க என்ன கேக்குறாங்க, they are asking only the charge and the bigger sphere ன்னு சொன்னா என்னது, இது என்ன C2 க்கு மேல they are asking what is the final charge. பாருங்க, Q2 dash is equal to what, C2 into V, அவ்வளவுதானா? C2 is what, 4 pi epsilon naught into 4 centimeters, sorry 3 centimeter, C2 oda value into இது என்னது 4 in 10 power minus 2 common potential, 4 in 10 power minus 2 by இங்க பாருங்க, இதுல 4 pi epsilon cancel ஆயிடும், இங்க என்னது 4 cancel ஆயிடும், centimeter cancel ஆயிடும், remaining is what பாருங்க, வெறும் அந்த 3 into 10 power minus 2 coulombs, அவ்வளவுதான். So this is what the charge on the bigger sphere. So bigger sphere மேல what is the charge, 3 into 10 power minus 2. Bigger sphere மேல what is the charge that is there, 3 into 10 power minus 2. So that's how simple. So ஏன்னா ஒரே format. So we'll have the maximum பார்த்தா இது இப்படி தான் இருக்கும், like they will give us the charges. Usually அந்த potentials கொடுக்க மாட்டாங்க. If they are giving potentials means you will use that formula. What is it? Common final potential oda value enna, C1 V1 plus C2 V2 by C1 plus C2. அந்த formula நம்ம யூஸ் பண்ண போறோம். They are giving initial charges means இங்க என்ன வரும், Q1 plus Q2 by C1 plus C2. அதுதான் final common potential oda value. Okay. அது இருந்தா அங்கல இருந்து we will just be able to easily calculate what is the final charges. இப்போ இந்த ப்ராப்ளம்லயே அவங்கள they are asking the final charge on the smaller sphere also. அப்ப நம்ம என்ன பண்ணணும், we just have to multiply C1 value with the common potential, அவ்வளவுதான். Here they are asking what is the final charge on the bigger sphere means what, the 3 centimeter sphere. So that is why we are doing what, அதோட அந்த sphere ஓட capacitance value C2 into the final potential. ஏன்னா finally both the spheres will have the same potentials, both of them will have the same potential. That is what we are calling as what, common potential. That is what we are calling as the common potential. Okay va? So this is how we have to approach questions where we are having this charge distribution. Okay, so paranga, even I think in 2 more other previous year papers we have got similar model of question, same, like they will give us 2 spheres, connect them via a wire, avladha. They will ask what is the charge ratio on the 2 spheres finally, or they will ask what is the charge on the smaller sphere, or they will ask what is the charge on the bigger sphere appadi. Okay, so approach எல்லாத்துலயும் ஒரே மாதிரி தான். என்னது, we will look at what is the final common potential, அங்கல இருந்து we can calculate what is the charge on the sphere 1 or what is the charge on the sphere 2 based on whatever they are asking. Okay va? So this is about the concept of conductor, particularly the spherical conductor acting as a capacitor. Okay va? So next class we will start with the discussion about the parallel plate capacitor. Adile enna theriyuma, adile we have even special case, maximum need syllabus enna we will have that parallel plate capacitor with equal area. Adu pathi nam discuss panna porom. Enna parallel plate capacitor also can be having lot of varieties. Okay, first nama parallel plate capacitor sonna enna solittu we have to understand. Adukapram we will be able to know what is this parallel plate capacitor with equal plate areas. Okay va? So we will talk about the parallel plate capacitors and the parallel plate capacitor with equal areas from the next class onwards. Okay, we will see in the next session.